Hello guys, welcome you all for this end-to-end session of AIML, where you guys gonna learn everything that you guys need in order to become a successful data scientist. Hope you guys are enjoying. We are enjoying a lot, and we are learning a lot each and every day. Hope the same thing for you guys. If you guys have any doubts, okay, till this, okay, just ping in the comment section. We will take up and we will solve your doubts. Okay. So, and one more thing, guys, we are having nearly 5,000 plus quizzes which are available and live in our YouTube channel. Please go and attempt it. It can be either right or wrong. Just go and give an attempt. Okay. And one more thing, guys. Please subscribe to our channel, because like every day we are just posting a new video. So whenever you subscribe and press the notification icon, you will be notified whenever we upload the new videos. Okay. So today's session is a continuation of previous session where we have introduced you to the technique called as object detection. So that's the reason I'm just insisting every one of you to watch at least previous session. As always, like I'm gonna suggest every one of you to watch all the previous session videos so that you can have a better understanding of what we are talking. Okay, at least for this session, make sure you guys watch previous session so that you can have a better understanding. Okay, let's continue. Okay, without wasting any time. So we have introduced you what is object detection, what are the best practices in object detection, what are the algorithms in object detection. Today we're going to see datasets and benchmarks of object detection. First is the COCO dataset. It's a very popular dataset. It's a larger dataset containing a size of nearly like 2 lakhs images and 1.5 billion object instance across 80 plus categories, where we're going to have 80 categories where we're going to have human, we're going to have something like a ship, and then something like helicopter. Like there are going to be n number of things which are available as an object in the COCO dataset. It's a pretend, like it's a base dataset. Pascal VOC, it's another dataset. It's a popular dataset for object detection and classification with 20 object categories and over 11,000 images. Here also there is something called as a cat, dog, so some common things will be there. ImageNet is a massive dataset of over 40 million images spanning 22,000 categories, widely used for object recognition tasks. Guys, this ImageNet is one which is built for deep learning purpose. Its dataset is very huge, so they are using for the computation task for detection purpose. Open Images, a diverse dataset of over 9 million images annotated with object bounding box, segmentation, and attributes, which is very helpful for us to easily do the object detection. Okay, guys, this COCO dataset, Pascal VOC, ImageNet, and Open Images are some of the datasets which are open source. I will say it's open source, it's very easy to use. Everyone is like a base for doing this computer vision task, any kind of computer vision task. Okay, so this is all about the object detections, benchmarks, and also datasets. Okay, so yeah, sir, over to you.
Yeah, guys. So, data sets and benchmarks. Okay. So, COCO data set, okay, it has largest data set containing 2 lakh images and 1.5 million object instance across 80 categories. So, it's a huge data set. Then Pascal VOC, which is a popular dataset for object detection and classification, with 20 object categories and over 11,000 images. Okay, ImageNet, again a massive dataset, over 40 million images spanning 22,000 categories. Right? ImageNet is like the one who made the breakthrough, guys, in computer vision. So it's a widely, like it's I'll say this is the best data set, and it has done a lot of breakthroughs. Like actually, computer vision got very popular after ImageNet performance. Okay, when it learned, widely used for object recognition tasks. Okay, then we have open images, which is a diverse data set over 9 million images annotated with object bounding boxes, segmentation, and attributes. Like what we have learned, that in the different four algorithms. So similarly, like you can use data sets for different features, like as per the objective function, what problem you're solving. So you can use it accordingly in computer vision. Uh, so you can see that it depends on your problem statement and what problem you want to solve. Okay, let's move to the other section.
Yeah, sure, sir. Yeah. Let's do performance evaluation for this object direction. What are the performance evaluation that we are having for this object direction? Okay, so first is precision. Guys, I hope like this everything we would have learned, but only thing which we gonna learn new is like this IOU. Okay, before that let's understand everything. Precision, the ratio of true positive detection to the total positive detection. Recall, the ratio of true positive detection to the total number of ground truth object. Effort score, which is like a harmonic mean of this both precision and recall, providing a balanced measure of performance. Guys, this is everything we have learned. Precision, it gives the accuracy of positive sample. Recall is gives the accuracy of both negative as well as positive sample. Whereas this effort score is a combination of this precision as well as recall. Okay. New thing that we're gonna see is this IOU. That is intersection over union. The metric that measures the overlap between predicted and the ground truth boundary box to evaluate localization accurately. Okay, let me put it in this manner. Okay, let us have something like okay, let us consider this is a palm. Okay, this is a hand, so this is a palm. For example, we're gonna detect this palm. This is a palm. Okay, so when we have an exact boundary box, then it is gonna say it as 100% IOU. That is intersection of union. Otherwise, if something like this one, it is saying palm, this one only. So we are leaving these things, right? In this AOU is somewhat deviated rather than 100%. So this is called as IOU. This is very important in object data, because in object data we will be creating bounding box, right? This is the exact and very important metrics which will be used for object detection. Okay. So yeah, so over to you.
Yeah, so performance evaluation metrics, guys, we have precision, we have recall, app score, we have we have learned these guys, like we have learned in machine learning precision, okay, the ratio of true positive, okay, detection to total positive detection. Like there we have data, here we have the images and videos or whatever. So recall, again, ratio of true positive detection to the total number of ground truth objects. So here data is different, concept is same. Okay, F score, again, harmonic mean of the precision, recall providing balance measure of the performance. So here the only difference is ALU, intersection over union, the matrix that is measured overlapping between prediction and grounded truth boundary boxes, evaluating localization accuracy. So this is like it is going to measure the overlap between predicted and ground truth. Again, the same thing what we do in recall and precision, like we check true positive and negative, whatever true positive or all, here we are checking with this overlap. So when you are checking the overlap between predicted and ground truth boundary boxes, evaluating localizing accuracy. Again, this is the difference is only this particular algorithm is just checking the overlap between predicted and ground truth. That is the only difference. Let's move to the other section.
Yeah, sure, sir. So that is what all about the performance metrics of object detection. Let's move on to the next one. So real world application, guys, as always, this is not limited to that. Let's understand what are the object detection algorithms, like applications that we are having. Autonomous vehicle object detection is crucial for self-driving cars to identify and respond to the pedestrians, like some kind of other vehicles, obstacles, some things. Okay, so like whether we can go there, okay, whether the road is free so that we can have a autonomous driving. Surveillance and security object detection can be used to monitor public spaces, detecting some suspicious activity and enhance the security. For example, if we attach this object detection model to the surveillance camera, we can understand, okay, these are the anomaly people who are coming, who are not registered within the company. We can have a database based on this object detection. We can feed images of the person. So me and myself and sir, we both are belonging to a company. Then we gonna have the model trained with our both images, so it will not say any kind of security violence. If someone else, then there are going to be security violence, which is done by using purely by using this object detection. Okay, then is robots and automations. Guys, it's simple. Okay, because like object detection enables robots to see is a feature which is given to the robots by using object detection. Then inventory management, so object detection can help in automate inventory tracking, optimizing warehouse operation, and reduce human errors. Okay, because this inventory management is very important when compared to like this real world application, okay, of this object detection, which is used to helps to identify and place the objects, okay, for this inventory management. So this is all about the application that we are having in this slide, like autonomous vehicles, surveillance and security, and then something called as a robotics and automation. Finally, we are having the inventory management. So it is not limited to this. There are n number of applications available for this task of object detection. Okay. So yeah, this is all about from my side. Yeah, sir, over to you.
Yeah, so real world application and use cases, guys. Autonomous vehicles, we can use it. And object detection crucial for self-driving cars, identify, respond to pedestrians or vehicles and objects. So even see, I'll tell you, object autonomous vehicles also you can use it for the cycles. You can use it for small vehicles, different category vehicles, trucks, different and other. You can also use it for other robots and stuff. Okay, so n number of you can use surveillance, security. Okay, robotics and automation. You can use it inventory management in big supply chain management companies. You can use it in big factories wherein packaging is done, where the in manufacturing also, guys, because manufacturing you can do automation because now 3D printing is coming. Okay, so you can automate completely end to end the assembly line. Okay, and which is already done. I think in manufacturing of cars 90% work is done by robots. Okay, so and other factories or other industries are going to use. So that is why AI is fourth industry revolution. It is going to disrupt each and every aspect of human life and whatever is associated. So learn deeply, guys, with long-term objective function, with patience, persistency, consistency, and perseverance, and reinforce learning 5 to 10 times. Learn each and every concept, what, why, and how deeply, and then you become world's number one talent. Let's go to the other section.
Yeah, sure, sir. Let's move on. Okay. Challenges and future direction, guys. I will not say future direction. It is presently happening. Like improving accuracy, we need to continuing to develop more robust and precise object detection model, especially for the challenging scenarios, guys. It's purely depends on the data and how we project the model, how we are training the model. Okay, for improving the accuracy. Real-time performance, performing object detection algorithm for a faster processing and deployment on resource constrained devices. Okay, so for inferencing this kind of model, we need the ample amount of CPUs which are available in this data set. Then domain adaptation, enhancing the generalization of object detection model to perform well across diverse real world environments. Okay, so this kind of domain adaptation is very important when we are going for object detection, because consider we are going for object detection of something like a car, okay, who crosses the limit. So we need to know what is the limit, then only we can apply the object detection. So these kind of things makes us to understand the domain better. Okay, next, interoperability and explainability, it's improving the transparency and interoperability of object detection model to build the trust as well as the enable better decision making. Okay, so these are some of the challenges and I will say present direction which are present in this YOLO, like that is object detection model. So like we are having something like a improving accuracy, and then we are having real world performance and domain adaptation, and then finally interoperability and explainability. So these are some of the challenges and future direction, but it is a present direction. Okay, there are n number of directions which are available. So yeah, because the slide can accommodate only these things. Okay, this for one. So yeah, that's all about the challenges and future directions. So yeah, so over to you.
Yeah, so guys, challenges are there in each and every model, and with challenges, we there are opportunities, and when there are opportunities, those are the future directions. Okay, so improving accuracy, I think every model we'll try to improve the accuracy, whatever algorithms we have. Then real time performance, we want every algorithm model to perform real time basis, optimize the objective function. Domain adaptation, we want it enhances the generalization of object detection, model performance well across diverse real world environment. Same here we want for computer vision in machine learning, in other deep learning and other, we everywhere we want to do that, right? The concept is same, the variability will be a little different, and interpretability and explainability again, for all the models whatever we have learned till now. And we here also improving the transparency, interpretability of the object detection, so it should interpret properly, build trust, enable better decision making. So this, the basic concepts are same, the just we need to do it as per computer vision here. Earlier we had to do it with as per machine learning, and deep learning we have to do in a different way. But the basic concept is same. No need to worry. Keep learning deeply. Understand the essence of the concept. Absorb it, digest, and apply. Keep learning deeply. Let's move to the other section.
Yes, sir. So yeah, I hope that that's it for today's session, guys. Okay, we have discussed what is object detection, what are the things that are available in object detection, um, some of the important key factors of object detection, everything we have learned. So today we are concluding with the challenges and future direction. So yeah, guys, that's all about today's session. So this is all about the object detection that we are having for direction of any kind of object in present in the images. So yeah, this is all about today's session, guys. We are continue the next session in the next day. So until next session, bye guys, take care. We will all meet in the next session. Bye guys.